not family, but a library of functions we talked about last time. Maybe one of which was something like y equals x squared. Do you remember what this looks like? Yeah, this one kind of, the shape is called a parabola. Without looking at your notes, just you and your neighbor discuss some of the library. I know it's been a long time since the library was closed, so let's see if you could bring back some of the contents.
I remember that. Yeah.
Oh, like,
Oh, yeah, yeah, yeah.
so like,
I'm like,
yeah.
something's like, what part?
X.
Which one? Which one was that? Yeah, it's X cubed.
Uh,
So you're discussing these with your neighbor. What do you remember from your library?
You want this? This. It's really, like it's happy. Oh.
Oh, if I have one, here it is. Yeah, I believe this is it. Yeah. Thank you. I was looking and then I got distracted. You got them all? Oh, you got three? Okay, so y equals x squared. How many points did I want to see for this one? Remember? Well, at least three. I want to see that one down here at the bottom, which is called the vertex. And then remember the delta y. Did we talk about that in this class? Maybe that's my plus one, plus three, plus five. So if there were a grid, I'm just gonna do a general shape right now. Oh, that's so bad on the left. Oh my gosh. And it's not much better. Okay, let me just get a few more from y'all. This one. One is right here. What's another one that you remember, Elise? Thank you.
Just in the.
So the first quadrant, could everyone just take your finger as a marker on the whiteboard in front of you and trace the square root of x? Comes from the origin, right? It goes this way. We still have that 1, 3, 5 pattern now, but now it's a delta x. So this, and you recognize that this is half of a parabola, right? Just the top half of a parabola if it were lying down. Thank you, Elise. Haley R., do you remember any others?
Absolute value is like.
Ah, nice. Y equals the absolute value of x, which you said it looks like a V. Does that sound about right? Your library is full. Let's see. Haley K, it's a Haley and Haley.
Y equals 1/x.
Y equals 1/x. Could you all show me what that looks like just in front of you? Could you kind of give me an idea? And for this one, it's necessary. So you don't hurt your wrists. The crossover, part of it's in the, which quadrant? One, it looks like this. First quadrant is up here, and then it's also in the third quadrant, which is down here like this. If you try to do this, it just, I can't stretch that much. And how many points do I care about here? I just care about 2 points, and it also has two. Check with your neighbor. What's the word? Two asymptotes. Two asymptotes, which is a line that is kind of a guide for these two. So there's one horizontal asymptote and one vertical asymptote going through here. You're going to learn a lot more about those next year. Something to look forward to. Haley, thank you very much. And at least you too, thank you. Look, was it like going in a row? I wonder what's going to be Kyson next. It's not. It's May, but she's not here, so maybe it will be. Let's see. Kyson, it's not you. I'm sorry. You sure? It is Joanna, though. What's another item in your library?
Y equals X cubed.
Y equals x cubed. Could you all show me what that looks like just in front of you? You could trace it with your finger if you like. It's in the first and the third quadrants, right? Going right through that origin. Here, a little bit steeper than a parabola, and then going down. over here. Yay. How many points do I care about on this one? I really care about the 3, but if you can fit it on the grid, I want to see that 8 up the top and -8 down at the bottom. Thank you, Joanne. Our library is getting pretty full. Charlotte, do you remember anything else? Y equals a cube root of x. Nice. Can you please trace, if you remember what this looks like, what does this, you could trace it. It's hard to, unless you want to do this. Full body. Yeah, so kind of like the square root of x going this way, but we also plug in negative numbers into our cube root function. Were there any others? I think there were 2 others. The easiest 2, perhaps. Y equals x, which looks like this. As a line. Slope 1. Kara, did I just see a little disco right there? Is that what's going on? I like it. Yeah. And there was one other one that we talked about, y equals b. Can you show me what y equals b looks like? It's just a, what kind of line? Thank you for not calling it straight. Why will I make fun of you if you call something a straight line in this class? The lines are always straight. So if you're describing a line as straight, I think you're being redundant. Of course, in the real world, it's not like that. If you're lining up something, you can stand in a straight line. This line could wind around. But in this class, if I'm asking for what kind of line it is, perfect description is horizontal for that. We know that the slope of a horizontal line is 0 because it has no rise. It has no rise. Remember, slope is rise over run, and vertical is, slope of vertical line is undefined because it has no run. I'm just going to see if you could do something now. Now that we have our library opened for business again, I just want to see if you could do this on your own grid. You can graph this. You can make your own grid. And when you make your own grid, you're just making X and Y axis. Make some tick marks appropriate. You don't have to go to 10 in each direction. Unless you need to go to 10 in each direction. Check with your neighbor when you are done or stuck. Okay, let's take out our pocket absolute value. Now, did you make a table of values here? Did you make an X and Y chart here? I hope not. I hope they use transformation. So let's say we start with this one. Go ahead and hold up your basic library. That V right here. So you please show me what that -3 is going to do to it. Kind of take it, that -3 is going to move it 3 to the right. Do we know it's right and left because it is inside the function, and then that 1 is going to move it up 1. So your graph should look like 1, 2, 3. That's a pretty important point, don't you think, for this one? And if I want to get the general shape, I'm just going to go up 1 and over 1 in both directions, 1 to the right, 1 to the left. Let's just make sure that this is right. How could I check to make sure that this matches the function that I've been given? By plugging in numbers. Like we could plug in the number 2. Like if we plug in the number 2, according to this, 2 should come out. Does it work? If you plug in a 3, does a 1 come out, just like it says here? It's kind of nice, isn't it, to just to get the graph. Once you have the basic function, right, the library, you just move that around. It's necessary. Does this ring a bell? It's been a while. Had you purged your brain? Had you purged it to make room for all that turkey? Who had no turkey this Thanksgiving? Just like curiosity, anyone have no turkey? I guess we all had turkey. No one had a tofurkey? Did you ever have tofurkey? It's not too bad. Do you know what tofurkey is? What is it? Tofu.
Food that should taste like turkey.
Exactly. Yeah. A vegan form of turkey. Not bad, actually. It's a good alternative. Cruelty-free meal. Always appreciate that. Okay, moving on. Let's get to the packet. Let's do today's lesson. We're going to do some more transformations. Day 2, transformations of functions. Here we go. Is this really a function? How do we know that's a function? Show me a good gesture to show that it's a function. You scan it, right? With that vertical line. So it passes the vertical line test. It never passes through any more than one point as you scan through it. You can see that it is represented here graphically and numerically. So to draw y equals 3 times f of x, notice that 3 is on the inside or outside of the function. It's on the outside, so it's going to affect it vertically, but this time it's being multiplied by 3, so I hope it makes sense that each y value will be multiplied by 3, tripled. So I'm going to draw the original in dashed form. And I will put that point in the right place. Now I could make another column here and I'll put 3 times f of x. Remember, f of x is just another way to say y. So in other words, so for that first one, it's going to be not a -1, but a -3. That 2 is going to turn into a 6. I know this is crazy. That -2 is going to turn into -6. We're just taking the y value and multiplying it by 3. So 1 becomes 3, 0 becomes 0 times 3, which is, oh yeah, 0. Okay, so let's graph those. So -4 comma -3. I can do green. I think that's what I did last time. -2 comma 6. 0 comma -6. 1, 3. And 4, 0. See what this is going to look like? Yeah, we see it. Well, it's hard to do these lines. The transformations we did last time. Oh no, maybe looks like a couple people are still doing this. They're trying to do a good job, and I appreciate that. Transformations we did last time were called. Do you remember what they were called? Is it in your notes? Did I tell you? Did I keep it a secret from you? Shifts. Last time it was a shift, like shift to the left, shift to the right, shift up, shift down. It's also called, I think I gave it one other name, didn't I? Starts with a T, did I not tell you? Not transformation, translation. It's also called a translation. Did I mention that? The shifts are called translations also. Notice that I still have the dash from there. It's definitely not a translation. It's not a shift to go from the original to what we've done here. Do you think it's called? It's stretch. In this case, it's a vertical stretch. Does that make sense? And I have a gesture for vertical stretches. Go ahead and take a look at me. Take a look at me. It's going to blow your mind. Grab it and stretch it by a factor of 3. And the thing that's right in the middle of what I'm pulling, what's right in the middle is what do you think? The x-axis is right in the middle. So that's what results in a vertical stretch, in this case by a factor of 3. So I'll write that in here. We'll go back to black. And quite honestly speaking, I'll just take it down. Although I did the chart here, pretty much never do that. So what I would do is starting over here. Let's put this back. I just take the y value, like that first one's -1, and just bring it down, multiply it by 3. So -3. Take that to 2. Now it's a 6. What was that? -2 down here becomes that -6. So I wouldn't actually make the table. I really hate tables, and I recommend that you stay away from them. Because we don't need them. Until you need them. I mean, they're there if you actually need them, but I'll guide you through without. Life is much easier without. Okay, so use a graph of f of x equals x squared to obtain the graphs of 2x squared and 1/2 x squared. Okay, so we know what x squared looks like. I'll put as many dots as I can for this. Up 3, then up 1, 2, 3, 4. Oh, just barely. This is going to be a dashed parabola. Bless you. If you have colored pencils or colored pens, now's a good time to use it, or just a pen and then a solid pencil or something like that, because we're about to have 2 different graphs on here. Notice that 2 is on the outside of the function. Make sense? On the outside of the function. So we're going to take our parabola and stretch it vertically by a factor of 2. Of course, there's nothing down on the bottom, so it's just kind of stretching from that x-axis. So 0 is going to stay 0. 1 is going to become 1. What's going to happen to that 4? Stretch to 8. Does that make sense? That point right there? Right, these values are just stretching up, doubling their length. This was up at 4, now it's up 8. So each one of the points that I originally drew will, if I can, be stretched. And you'll see that I can't do that last one. Just can't happen. And now we can draw this in, and you may want to do this with your pen just to differentiate it, or a solid pencil in this case, whatever you like. I'm lucky enough to happen to have my my fuchsia marker. So that 1/2 for h of x is on the outside of the function, which means all the functions will, in this case, not be stretched. In this case, it's going to be The word is compressed. Compressed by a factor of 1. So do you see where all these points are going to go? Like that 1 comma 1 is going to become 1 comma 1/2. 2 comma 4 is going to become 2 comma 2. 3 comma 9 is going to become 3 comma 4.5. I hope that makes sense. I don't have to count again if I did it correctly on the right. I know it's symmetric with respect to the y-axis, so I'll just do the same thing on the right. Before we draw it in, I want you to recognize that from this dashed parabola to the green one, do you see that it is a vertical stretch? Does it make sense that all those points are stretching up, therefore becoming narrower for this parabola? And the same thing is going to happen with the compression. It's actually going to become wider. Let's not go up this fast. That's a pretty color. I should definitely use this more often. Do you agree? You're like, I see nicer colors. Okay. Hey, welcome back, everybody. First day back. I know it's tough. Any questions? Okay. Well, let's get this thing going. So summary, vertical compressing is stretching. So A is greater than 1 stretches the graph of f of x vertically by a factor of A. Cool. And if A is between 0 and 1, it compresses the graph of x vertically by a factor of A. Multiplies each y coordinate of y equals f of x by A. Yeah. Should I write it here? Like vertical compression by a factor of 1/2? I feel like compression is much too long for me to write. I think you already got it. Okay. Uh-huh. Here, this is where things get crazy. You recognize this function? Do you think this is one you should keep in your library? No. This is a random function that math teachers like to use to share a concept. Oh, messed up here. Okay, so I'm going to dash in my original function. Oops, I can't start with red. That makes no sense. Okay. Do you have a dashed like my hopes of ever having a real friend? Okay, so notice that 2 is on the inside of the function, isn't it? Which means that it's not the y values that are going to be changed, it is the x values that are going to be changed. So it's no longer going to be vertical, it's going to be horizontal. So please show me the gesture you think is going to happen with this function, with that 2x on the inside. It seems like it would be a stretch, but remember what's on the inside is opposite of what you think, like that x, like for the warm-up, remember it was opposite of that, was it a -3 and it went to the right? It's opposite of what you think. So that 2 on the inside actually results in a horizontal compression, in this case by a factor of 1/2, which I know is weird, is counterintuitive. Anytime it's on the inside of the function, counterintuitive. vertical compression by a factor of 1/2. And the 1/2 is just, of course, a reciprocal of whatever that is. So in other words, that first point, -4, comma, -1 is going to become -2, comma, -1. And let's just verify after I finish this. That -2, comma, 2. You see what's going to happen to that? Because in my compression, right in the middle is the y-axis. So this just gets half the distance to the y-axis. What's going to happen to 0, -2? Stays right there. 1, 1 becomes 1/2, 1. And 4, 0 becomes 2, 0. You see it's become compressified from the basic. That's I like to leave the dashed one there so you can see the smush. You could call it a horizontal smush if you like. Oh my gosh, I said vertical, didn't I? It's definitely not vertical. That is for sure horizontal in black. Please don't forget to correct me when I mess up like that. Horizontal compression. Okay, but let's check. What point, what x value can I plug in to check to see if my graph matches the actual function? Well, I'm going to start with the leftmost point when x equals -2. So if x equals -2, means that this is going to become f of 2 times -2, isn't it? Or f of -4. Do you know what f of -4 is? We check with your neighbor to see if they know what f of -4 is. And show me your answer when you have it. Do you know what f of -4 is? You have to look at your function, right? Where the function was given to start with, f of -4. We see here f of -4 is -1, or we can see it here, -4 is -1. So when you plug in the -2 into this function, out comes that -1. It worked. I'm going to ask you to take my word for it at this point. If it's inside the function, it's counterintuitive. Does that phrase make sense? Counterintuitive? Like counter means against your intuition. Like we seem to be multiplied, but it's a stretch in this case. Sorry, a compression by factor 2, which means for B, this is going to result in a horizontal stretch by a factor of 2. I'll give you a moment to graph that. Check with your neighbor when you're finished. Or if you have no idea what's going on, check with your neighbor, see if you can figure things out. Did I get it? I want to hear the points when you're ready. So check with his neighbor. I will be calling on one lucky young individual. Kyson, it's not you. I'm sorry. We went the other way. It's Ella. Ella, can you tell us the points that you got here?
-8, -1.
Are we good with that, everybody? Okay, thank you.
-4, -2. -2, or 0, -2. 2, 1. Then 8, 0.
Thank you very much. Do you notice that they quietly changed the size of the grid for you for this one? They accommodated you here. Like, shh. Thank you, Ella. That was great. But let's just check one of these to see if it actually worked. Let's check what happens when x equals 2. If x equals 2, that means we have f of 1/2 times 2. Does that make sense what I'm doing right there? And that becomes f of 1. Do we know what f of 1 is? We know from the basic graph, f of 1 is 1. We can see it here on the table. We can see it here, graphic speaking. We can see that when I plugged in 2 here, out came a 1. It works. It works. So go with it. Yeah. Okay. Horizontal compressing, stretching. Y equals F. Okay. Okay, what we just did. Can I give you a moment to decompress until, let's see, we have until 2:22. Feel free to talk or sing if you like. I know you want to sing. At least it's not a bad sing.
Is there a quiz on this?
Oh, it is. Yeah, good point. Thank you. Thank you. I forgot to mention it. I'll mention it right after the break. I don't want to give you business during break. I'll show you here though. Forgot. Thank you. Here you go. There you go. I forgot. Thank you. Yeah, there'll be like a little bit extra stuff. Who is tested? That's life. Life is a test. No?
Oh,
Oh, that's nice. You know that one? Okay. That's a white person song. Yes. The cars. Yeah.
Actually, no, we are back on today.
Why do we test the 4 lines?
No, we're back on.
Do we?
I always test them back where everyone else. There isn't like an issue, but it feels like in the pursuit of true fairness, like the chem department, they switch up like which day is taking what. So like the even days are not as taking it. As an odd day, we always take.
Exciting. You like trendsetter.
And wait, so are they taking it on Monday?
I think we may have some. Maybe should I think we might take it on Thursday. Not sure.
Yeah, so like. I would love that also.
Yeah.
Maybe like we should just take the test.
Right now.
No, I just feel like I'm sorry for taking like. And then like the 6 2 classes in the next, like what if we just like don't learn anything else? What if we just have fun? Because we're not gonna remember it over winter break. I feel we should just like do like fun maths.
Oh, I feel like that's quite redundant.
Say something about.
Okay, let's try it again.
Oh, I mean.
Oh my goodness.
When's our midterm?
Good question.
Yeah, it's on like the 14th.
Okay, folks. I completely forgot to tell you I've completed the calendar, and at the end of this week we do have a little quiz, which is going to include what we did last time, today, and next time.
Yes, can you build a little bit faster?
Oh, sure.
If the quiz.
Yeah, it's a really short unit. So,
We'll have 2 classes before you test.
well,
After we take the quiz, which is the last.
after the quiz, we'll have the review and then the test.
Oh, there is a quiz. That's right.
Oh, yeah, there is a flex day next week. Is that what the missing piece was?
Yeah. Quiz on a Friday and then have a test on the next Friday.
Oh, right. True. That would make sense. So yes, that it seems like many of you have noticed after this test, we will still have a week. And since I see you on Monday, that means I just see you Tuesday, Thursday, right? Life does go on, math life does go on. We're not just gonna stop because you're planning to forget everything you ever learned in those 2 breaks, not 2 weeks of break. So we are going to continue. And we'll hope for the best. The calendar does not work out in our favor. The testing calendar is when we have it. So we're kind of forced into this situation. But at day 4, we're going to have a little bit more chapter 2.6 and then finish the quiz. Okay, back to business. Okay, so everyone's attention. Graphing functions using reflections about the X and Y axis. Have we talked about reflections about the X and Y axis? Oh, we talked about symmetry with respect to X and Y axis, didn't we? Okay, so these are related. In this case, notice that this negative is that inside the function or outside the function? It's outside the function, so it's out here, outside, which means it's going to affect the X values or the Y values. It's going to affect the Y values. So if we have like a random point here, I hope it makes sense that if the Y values are affected, it's just going to go here. Does that make sense? Becoming a reflection over the X-axis if that negative is on the outside of the function. Of course, if it's on the, like this, it's on the inside, this is going to affect the X values. So that same point I was talking about before, that was over here, is going to go at X, and just flip on the other side of that Y-axis. So here, it's going to reflect over the Y-axis. I'll put this here, reflect over X-axis, reflect over the Y-axis. Okay, step 1 for A, I'm going to draw my original function dashed. I'm going to do it twice because it's annoying and I want to get it over with. It's annoying, but essential. Just remember for that first one, the negative is on the outside of the function, so it's affecting the y value. So I'm gonna take that leftmost point, which used to be at -4, sorry, -4 comma -1. Now it's gonna be at -4, +1. It's just each one is reflected over the x-axis. The other one that's at that used to be at -2, 2, -2, -2. Do you agree that's kind of a pleasant process once you just take one point at a time? No? Peter. Hopefully it's not the worst thing you've had to do. Okay, I'll take it. I feel like I messed up on that. This one over here. Yeah, I did. There's that one. And the other ones, I'm gonna again start with that leftmost point in -4 comma -1. And since that negative is on the inside, it's reflected over the y-axis, so it becomes 4, -1. And do the same thing for each of the other points. Check with your neighbor to make sure everything's making sense. There we go. Functions have been reflected. Answer any questions? Actually, question is, can we learn some more? Then the answer is yes. Yes. Okay, so it's all here. Look at this. There's two different things going on here. Would you please discuss with the neighbor what's going to happen to the square root of x? Okay. So this negative is on the inside. So if you show me in gestures what that would do. On the inside, so it reflects, it's a horizontal, so it's reflecting over that y-axis. And that 2 is on the outside, so it's going to move it up. So let's start with our library, our square root of x. Boom, boom, boom. And it's dashed. I recommend highly that you do them, but if you just want to keep it in your head, I won't take off as long as the end result is fine. So I'm going to take 1 point at a time. I'm going to reflect it over the y-axis and move it up 2. Does that make sense? Well, I'm going to give you a chance to do it. You can do this. Oh, just a minute. Oh, what is the question? It means it's a negative. I'll touch on that in just a moment. I know that's the worst answer. Remember, negative also means opposite. But trust the process and see what happens. Flip, move it up. Nope, flip it. The other way. Did you get something? Like that 0, 0, when you flip it, doesn't do much, does it? But then you move it up. Do y'all have this point on your graph? And that 1, 1, when you flip it, it's going to go to -1, comma 1, and then up 2. Is that clear? It flips over to right here where you can see my cursor, and then up 2. 4, comma 2 is going to flip to 4. I'm sorry, -4, and then go up 2. So -4. It was here, and then up 2. Do you have those same 3 points? Let's see what the shape looks like. Do we see that it's exactly our parent function from the library that's been reflected and shifted? Now, it's a little bit uncomfortable to have that negative in the square roots. Do you agree? But let's see if it worked. What values of x would be convenient to plug in to this function? Well, let's see the points that we have. Like, yeah, let's see what happens when you plug in a -1. What happens when you plug in a -1 right here? Becomes 1. Square root of 1 is 1 plus 2 is. Does it match? It's kind of perfect. What would be another nice number to plug in based on the graph? -4, right? We can see right here. Hopefully, when you plug in a -4, the output is 4. If the world is right, does it work?
Yeah.
It's perfect. We're not actually plugging in negative numbers into radical. We're plugging negative numbers into the x, which are being flipped around and made into the real world. There we go. What's the domain of this function? Check with your neighbor. What's the domain?
Infinity. Well, yeah, infinity. Well, you're being right, 2 constant.
Okay, so the domain starts at -infinity and goes all the way to 0, including 0. Yeah. Do you know the range? The range is from 2 to infinity, floor to ceiling, always. But it's not even asking. That's extra for free. Okay, now the order of things. You know PEMDAS? Okay, I'll forget about it. Well, forget about these two. That's the order that we do this in. So if you see multiplication, division, those go first, and then addition, subtraction order. Now the parentheses play a different role. That just tells you if something is inside or outside the function. Exponents play a different role. That just tells you if it's like x squared. It tells you the library that you're using. So all we care about is multiplication, division, addition, or subtraction. All right, so do multiplication, division first, and then addition, subtraction. And you know that for multiplication and division, it doesn't matter which comes first, does it? So really, it's like first multiplication, division, then addition, subtraction. So always do it in that order. So for 6, should we do the exponent first? No, that's not part of it. The exponent there tells us that we're dealing with, can you show me what we're dealing with here? Yeah, but we are going to do the thing that multiplication, is there any sort of multiplication or division happening here? Yeah, the what's being multiplied? The -1, which is going to take our parent function and flip it over or reflect it over the x-axis. And then the 2 is going to move it. Now 2 is inside, so it's 2 to the left, counterintuitive, remember that. And then 4 is on the outside, so it's going to go 4 up. Does that make sense? So yeah, if you want to just go to it, because we already have what we're dealing with here. If you want to go right to it, you can, but I always like to start, especially when I'm beginning, with the dashed version. I usually do the right side first for no reason. 0 reflected over that x-axis becomes 0, then 2 to the left and 4 up. Need green, it's back right onto another one, that's fine. And maybe from there, I'll just do my 1-3-5 pattern. What do you think? Would that make sense to just do the 1-3-5 from there? Once we have that vertex, we already know what's happening. You could take it one at a time if you want. We could take this, go reflect over here, and left 2, and then up 4, 1, 2, 3, 4. But I'm already there. In fact, I have my 1-3. I'll do 5 as I can. Because I'm conscientious here. I want as many points as will fit on the lattice that I can. Would you have rather done this with an X and Y chart? Hopefully not. I mean, you can. That's the last order of business, and I promise I will take off points if that's how you're doing it. I won't take off all the points. I will take off a couple points for depending on the XY chart. I want you to have the library. I want you to be able to move it as necessary. Do you have some more practice problems here? Oh, look at that. We do. Look at all that glorious fun. Oh, there's no translations here. Sorry. All stretches, compressions. I'll give you a moment. Do one at a time. Check with your neighbor. As you do them. Do you need a refresher for what that parent function looks like for number 1? Yeah, it's that kind of an S curve. It has 0, 0, 1, 1, and then 2, 8. Honestly, for the parent function, I don't mind you kind of doing a quick XY chart in your head. But I do want you to get familiar with them. Dashed. One at a time, just check with your neighbor. So, feeling released something. Thank you.
Yeah.
Yeah.
I'm going to stop the home video here and hope they could do it on their own. But we'll continue.